Good afternoon. Today we are going to work on writing equations for proportional relationships when we're given a graph. And this lines up with IXL assignment JKH. So let's start off with reminding ourselves of what a proportional relationship looks like on a graph. So on the left here in green, this is an example of a proportional relationship. There are two key things that we're looking for. So one is that we have a constant of proportionality, which can also be referred to as your slope, and that is the same for the entire graph. That's what makes a straight line, is because it's either increasing or decreasing by the same amount, keeping it a straight line. It can be at a diagonal, as this one is here, but there is no curves or bumps or anything. It is a nice straight line, meaning that this does have a constant of proportionality. The second thing that makes it a proportional relationship is that it goes through the origin. So that's that 0, 0 point. That's the center of your graph. Those are the two requirements that make something proportional, which is why this one over here in red is not proportional. Yes, it is still a straight line. It does have, in this case, since it's not proportional, it would be referred to as a slope. It is increasing by the same amount every time. But because this graph goes through the y-intercept of 2, and not the origin, that's why the red one is not a proportional relationship. It doesn't meet both requirements. When we look at that as an equation, because we're going to be writing equations from graphs today, if it's a proportional relationship, it's in this form. Y is equal to kx, where that k is going to be a number, and that is your COP, your constant of proportionality, how much it's either increasing or decreasing by each time. All right, let's head on over to IXL and get some practice in. All right, here we are on IXL. The code is JKH. Write equations for proportional relationships from graphs. Before we get started, please remember that IXL has some awesome resources too. You can click on this down arrow to learn with an example. So it's basically like you would see in a textbook where it has, walks you through step by step. Or you can watch the video that IXL has made for you, which is really great. It's always helpful to hear things more than once and hear it from different perspectives. All right, now that I got that plug in, let's get going. So Dakota has written her own recipe for pot roast. There is a proportional relationship between the weight in pounds of the pot roast, X, and the total cooking time in hours, Y. And then we have it graphed right here. We want to write an equation for the relationship between X and Y, and we are to simplify any fractions. Well, two things we need to remember. One is the equation for a proportional relationship, which is what we have here. Not only did it tell us that, we can see that it is both a straight line and it starts down here at the origin 0, 0. So it meets the two requirements. But that equation for a proportional relationship is y is equal to kx, where k is our COP, our constant of proportionality. And that also can be referred to as slope, just depending on which vocabulary word you've heard. When we're finding our constant of proportionality, that K value, we can find that by identifying the relationship between our X and our Y values. So we identify and discover that it should be how much our Y value increases by over how much our X value increases by. So if we look at our graph here, we can see that it's starting at 0 and it goes, oops, that's not a very good line, that it goes up 1, which would be our Y value, and it goes over 1, which would be our x value. And that takes us to the next spot on the graph, because anytime our graph crosses the grid lines, you technically could put a point right there. So we're going up and over 1, which means we'd have 1 over 1. And looky there, 1 divided by 1 is simply just 1. So that means our constant of proportionality, our k value, is 1. When we write it as an equation, we must remember this is our equation format. IXL already has the y equals for us, so all we would need to type in would be 1x, and then it would mark it as correct. Let's try another one and we'll look at it just a little differently so you guys can see if there's, one method or the other that, works better for you in your brain. So every day after school, Albert and his sister Valentina play their favorite video game, Wizarding Legends. The goal of the game is to earn power points by defeating goblins. There is a proportional relationship between the number of goblins defeated X and the number of power points earned Y. Write an equation for the relationship between X and Y and simplify any fractions. So the important thing for us to remember is we honestly just need to find our K, and that K value is your Y divided by your X. Because this is a proportional relationship, there is something special that we can do. We can either do it like we did before, which is where we do that rise over run. We see how much our Y is increasing by, and then we see how much our X is decreasing by. But with proportional relationships, there is, a special way we can do it, because in order for them to be proportional, they always start at 0. So since they always start at 0, we could honestly just look at the very first point on our graph. So that would be a point where our X value is 1. So if we come all the way up, that would be this point right here. And this ordered pair has an X value of 1 and a Y value of 7. So we can simply just take our Y and divide it by our X from our ordered pair, which would be 7 divided by 1, giving us a K, giving us a constant of proportionality of 7. And then remember, when we write it in our equation is in the form of Y equals KX. So we need to type in that 7X. So that's another way to look at it, to kind of prove to you that it's the same method as before. If we take my little spotlight tool here and we start at the 0, we count up 1, 2, 3, 4, 5, 6, 7. Looky there. And we count over 1. Just we can, look at the first point only and not even do the counting whenever it's proportional and starts at 0. All right, let's check this one out. This question's just a little different. Anne wants to fill her water bottle between classes, but the water fountain next to her classroom is frustratingly slow. This graph shows the relationship between the amount of water in ounces Anne puts in her water bottle X and how long in seconds it takes to get that amount Y. And we are being asked at the bottom here, do X and Y have a proportional relationship? Well, the two things that we look for when we're given a graph is it's a straight line and it starts at the origin, 0, 0. Does this meet both of those requirements? It sure does. I don't care that my line's at a diagonal. It is still a straight line. There's no bumps or curves in it. And it does in fact start down here at 0, 0, which would be yes. Now that we have said yes, part B pops up and we are being asked to write that equation since it is proportional. All right. That means we are starting here at 0, 0, and no matter what method because I've done two examples, no matter what way you look at it, you need to find that first ordered pair, that first point. And to find that first point on your graph, you're looking for where the line intersects a grid line perfectly. Where if we go to the very first point, that's right there. I don't really know, like, that's close to halfway, but not quite. There's too much guessing, there's too much estimation. And same for this point right here. That's not right on a grid line. I'd have to estimate its value. Same for here, same for here. So it's not until this point right here that we finally cross that intersection. Let's clear all this so it's not too confusing. So here is the point that we will be dealing with. To find our k value, we take the y and divide that by the x. So we'll go ahead and we'll do both methods on this one. Our y value, looky here, lines up with 10, and our x value lines up with 5. And if you were using the rise over run method like you would with slope in your counting, notice that your y's count by 5, so we would go up 10, same answer, and we'd go over 1, 2, 3, 4, 5. Last time I'll say this, sorry for the repetition, but please remember this little shortcut of just taking your first ordered pair and going y divided by x. The reason it works is because it's proportional, because it starts at 0, 0. If that graph started anywhere else, if it wasn't proportional, then that trick wouldn't work and you'd have to do the rise over run counting method, okay? All right, but if we get back to it, we have a fraction here, 10 over 5. Our directions tell us to simplify any fractions. That's easy enough. 10 divided by 5 is 2. Meaning our equation is y equals 2x. All right, next question. When a truck full of boxes arrives at the Oxford post office, Troy unloads the truck by placing the boxes on a conveyor belt. Troy's coworkers were impressed with how fast Troy does his job. This graph shows the relationship between the time in minutes Troy puts unloading the truck X and the number of boxes he unloads from the truck Y. And we first off want to know if this has a proportional relationship. Well, remember the two requirements are 1, it has to be a straight line, which we have here, and 2, it needs to start at our origin, 0, 0, which this in fact does. So yes, it's proportional, which means part B, of course, is going to pop up, and we now need to find that proportional relationship, or that constant of proportionality, so we can write our equation. All right, this is another one where we're going to have to look really carefully to see where that first exact point is on our line, because we don't want any of the points that it falls between grid lines, because we'd have to estimate, and my guess maybe like be different from yours. So that doesn't meet a grid line perfectly. If we kind of come over here, like where my red dot is, that's a perfect grid line. That's a perfect grid line. So it's where both of them meet up. So if I follow this along, I have no intersections with grid lines until I get all the way up here. So that is the point that we will be using. And because this is proportional, we can use that little trick where we just take our ordered pair and divide our x and our y and our x values. Sorry, it's important to do it in the same order. So our y value here would be 45. And then our x value, oof, that's a terrible line. Our x value here would be 10. And we want to simplify that fraction. Well, 45 divided by 10 doesn't go evenly. And it's not telling us that it's acceptable to write our answer as a decimal point. So we need to keep it as a fraction and just simplify. So what is something we can divide both 45 and 10 by? We can divide them both by 5, because remember, if numbers end in 5 or 0, they're divisible by 5. So 45 divided by 5 would be 9, and 10 divided by 5 would be 2. Can we simplify that fraction any further? Nope, they don't have anything else other than 1 in common, meaning our equation, our answer, would be y is equal to 9 over 2x. And then we can insert that with the little slash for our fraction there. All right, we're going to do one final example here. Celine is passionate about movies and dreams of going to film school. Her goal for the next year is to watch every movie that won the Academy Award for Best Picture. She's already seen some of them and now plans to watch one per week until she's seen them all. This graph shows the relationship between how long in weeks Celine has followed her plan X and the number of Best Picture winners she has seen Y. We want to know if X and Y have a proportional relationship. What do you think? That would be a no. It doesn't meet both requirements. In order for it to be proportional, it has to be a straight line, which it is, but it also has to start at the origin. It has to go through the origin, and this graph right here starts probably at about 5-ish, and the origin is way down here at 0, 0. So this would be an example where it's not proportional. Oops. And because it's not proportional, it's not going to ask us to write the equation, because the purpose of this IXL assignment is only writing equations for proportional relationships. So because this is a no, that's all you would have to do, and you can move on. All right, it's now your guys' turn to try it. If you need to do any drawing like I did, where you find that point and you kind of draw it on there to make it easier for you, remember IXL has this handy dandy pencil tool, so you're able to write on your screen just like I am, and you can even change the color to red if you wish. All right, get started. Work on this, and if you need any help or have any questions, come to a help session or send an email to your teacher. Bye.